G'day and welcome back to RC Model Reviews on the bench. Today I have, well, this is actually the Durafly Tomahawk from Hobby King. Actually, I like it. I've been flying it a lot. It flies really nicely. Top model, excellent model, I have to say. And why have I got it on the bench? Well, I've already reviewed this model. It's not a review of the Tomahawk. It's a review of what's in it. And what's in it today? Well, interesting. Let's take the lid off it and have a look. And as you'll see, this has a R9, a FrSky R9 receiver in it. And that is the 900 megahertz system, the long range system from FrSky. Let me turn it around so you can read the label. See, R9, that's what it says, must be true. And of course, the R9 has with it, excuse me, put the lids back on things. The R9 has with it, of course, the M9, that's the module. It's an R9M, yes, the R9 module. There it is. Simple, isn't it? Yes, lots of people have been sort of looking at this and doing little reviews and talking about it. But of course, this is RC Model Reviews. We're not going to fiddle around just looking and saying how lovely and shiny it is and how it goes with the curtains. We're going to have a technical look at it. We're going to see what's inside. We're going to look at the technical side of things and decide, well, try and decide whether it's worth buying from a technical perspective. And yeah, we'll test it out and see how it goes. Right. First of all, let's have a look at the module. It's a standard FrSky/JR type module, and I've got my QX7S here, which is also a wonderful radio. In the back of the QX7S there is a module bay. This simply plugs in. Simple, isn't it? But don't turn it on yet or you'll blow it up, because you've got to put the antenna on. It has a simple whip antenna, which is going to be more than good enough for most applications. I see a lot of people now want to put Moxon antennas on and all sorts of high gain antennas. No. What you have to realize with transmitters is you don't really want a directional antenna on your transmitter, because then you have to stand and point your antenna directly at, or point the directional element of the antenna at the model. And if you're flying a long way away, do you know where the model is in relation to yourself? You're going to have more than enough range to fly well beyond the rules with the standard setup. So I wouldn't recommend people go out and start putting high gain antennas on here, because also this module can produce quite a bit of power. It does up to 2 watts according to the, well, the chipset can do up to 2 watts. I don't know whether it actually does 2 watts or not. Maybe we'll measure it. But it can do up to 2 watts, let's say, and that's a snot load of power. So if you get an antenna on here that's not perfectly matched, if you've built it a little wrong or you don't have an SWR meter to make sure it's matched to the module, you can blow the damn thing up. It'll run hot and then it will just stop. So it's better to just use the stock antenna, and you're going to get, oh, in fact, we might do some calculations later to see what sort of range we should get in theory. But in theory, it's a snot load. So that's all you need to know, really, a snot load. Remember, of course, that in virtually every country in the world, it's illegal to fly beyond the beyond visual line of sight. And so something to consider. One thing I've noticed, see, look, it's on the piss a bit, isn't it? This SMA connector on the back of that transmitter, on the back of that module, is not level. That's a bit shoddy with the quality control, but we'll take a look inside and see if the important bits are important. This is purely cosmetic, and maybe it'll help. If you've got one short leg or your name's Eileen, this is just the module for you. Right, I want to take a look at the receiver here. This is the R9 receiver, and it has these antennas which, they're basically a flat flex printed antenna, which are quite good on this wing. It makes for a really nice installation, doesn't it? So they just tape along the wing. They're not 90 degrees apart. I'm sorry, I couldn't get 90 degrees out of it. And they're only horizontally polarized, which is another issue, because normally your transmitter antenna will be vertically polarized, so you will get a cross polarization loss. But we do have a lot of what's called link budget here, which basically means we've got range to burn. So it doesn't matter too much if this isn't perfect. We're still going to get, several kilometers, 10 kilometers perhaps, I'm just off the top of my head, 10 kilometers like this without having to worry about the exact polarization of those antennas. Right, I'm going to show you what happens inside the transmitter when you install one of these modules. And here's my QX7S. I'm just going to go into the menu page and I'm going to go to the setting down here. Now when you set these up, of course, let's go up here. Everyone who uses OpenTX will be familiar with this. Under the setup we have internal RF is off. Turn that off, because we're not going to use the 2.4 gig internal transmitter. We're going to use the external RF, which is the module. We set it to R9M, and simple. All the other controls work the same. The only thing we have added is the power level, and we can change the power level on this. Let me show you what you've got. You've got 10 milliwatts, which is, if you're just flying around the backyard, well, that's fine. Batteries last for a long time. 100 milliwatts, that's the same effectively as your 2.4 gig system, but you're going to get a bit of extra range Anyway, because of the lower path loss. Talked about that in a previous video. Go and watch it if you're not sure what I'm talking about. Lower path loss at 915 megahertz. Then we have 500 milliwatts. Ooh, that's more power. That's going to extend your range, but not by as much as you might think. It'll probably double your range. And then if you really want to go a long way and cook some eggs in the process, you have 1 watt. It only does 1 watt. Okay, there you go. I should have looked at that before, shouldn't I? So although the chipset will do 2 watts, it's only set up to do a maximum of 1 watts, which is 10 decibels more than standard. So that's quite a bit. That's going to extend your range. That and the lower path loss means you've got, and the high sensitivity too, because I'll talk about the receivers. They have a very sensitive receiver, which means you can get a very long way. But I'm going to leave this on 100 milliwatts for now because that's all I need to fly around here. And that's it. That's really all you need to do. Binding is the same as the other FrSky stuff. No big deal. And that is what you need to do on your transmitter side of things. It's a piece of cake. Okay, let's take a look at how this transmitter handles the band. As you can see, there we go. Look, that's chonking up a fair bit of bandwidth there. It seems to be centered on, where are we, about 915 megahertz, which is what it should be. Let's make some markers here. Where are we? So it goes from about, looking at the frequency here, where am I? I've got to find the right part of the screen to look at. From about 900, whoa, this is from about 900 megahertz up to 925. So it's using 25 megahertz of the band. Actually about 904 up to 925. So it's using about 20 megahertz of the band, which is probably more than it should, I think. I have to check the specs. But okay, so it's using a fair chunk of the 900 megahertz band, which is good because the more of the band you use, then the less, or the more room there is for everyone to fly along. And you can see it is spread spectrum. I'll go back to my calculation mode here, and I'll just, there we go, see how in fact I'll change modes here. So we'll go to normal, and you'll see the different frequency hopping around there. It doesn't seem to use a lot of channels within that band. You can see it sort of hopping quite noticeably. So yeah, it's frequency hopping, and it's on the 900 meg band, and it seems to use a snot load of it. So from the point of view of your model, it's great. From the point of view of compliance, I'm not so sure. I haven't checked to see whether this has got an FCC label on it or not. It may or it may not. Let's have a look now. Just turn this transmitter over. I don't see an FCC label on it. So that probably says it all. I will need to do some research. I haven't actually checked what's legal in various countries. So yeah, and well, I guess we'll find out. But that's what the frequency use looks like. And this is what the output from the receiver looks like. Yes, that's right, the output from the receiver, because it does have a telemetry link. So this receiver is sending back data to the transmitter. And in doing so, there we go. It's also hopping all over the band and transmitting. And actually, does it go a bit higher? I think this might, let's just go back to the, where are we? Let's go back to calc and to max mode. Is it using, yes, look, I think it's, wait till it builds up and I'll use some marks. I think it's actually transmitting over a wider range of frequencies than the, there we go, it's filling out its nice little band curve there. Let's put a marker on here, and yeah, maybe because I'm because I'm a bit close, but it's going to 925 there. So yeah, it does use the same band. It just looked a bit odd to start with, 903 to 925. So yeah, it's transmitting back. It's transmitting the signal back. But of course, the transmitter power on the receiver, the telemetry broadcast, is only going to be at 100 milliwatts. The transmitter can go to 1 watt, so you may lose the telemetry long before you lose the RC link. Not too much of a problem, because in most long-range stuff, people are flying FPV and they have an OSD, so telemetry becomes kind of secondary. It's, you can see on the screen what you need. So, telemetry is a bit of a bonus that probably won't be as widely used as you might think with a long-range system. Right, let's take a look at the transmitter module this time, and I'll give you a little bit of a guided tour in terms of what the things in here are doing. All these magic components where the pixies live, I will try and give you an idea of what they do. Well, first of all, here is the magic chip. This is the LoRa transceiver chip that exists in the receiver, as well as, of course, there's one in the transmitter, one in the receiver. But they, because of the telemetry, they both, in each, whether it's in the module or whether it's in the receiver, they both send and receive. So it is indeed a transceiver. Now, this little chip here does all the magic work. This is a really goody chip. I will link the the data sheet for this chip into the description of this video. So if you want to see exactly what goes on and all the technical elements, you can go and look at the data sheet. It will tell you all the wonderful things that this chip does, but I'll speak about it a bit more in a moment. Suffice to say, this is either listening or talking, and it's the transmitter module, so it spends most of its time talking. So it creates a signal which comes out here and then goes into a, what have we got here? I can't see because I'm looking. I think this is the power amplifier. This is a 2-watt power amplifier, 2 watts. So this can chunk out up to 2 watts, depending on the settings. And then it comes through here, and here's a little switch, because this can switch backwards and forwards between the receiver and the power transmitter, the power amplifier. Because obviously, if you're transmitting, you want the signal to go through the power amplifier and out through the antenna. And if you're receiving, you want it to come in the antenna and bypass the power amplifier, because it would just get in the way. So this little switch switches backwards and forwards between the input and the output on here. So you can see tiny, tiny switch. These are all made by Sky. These chips are Sky chips. This is a LoRa chip. It's a long-range radio chip. The rest of the stuff's pretty mundane. There's a beeper here. We've got an XT30 connection if you want to run the higher power levels and not drain your transmitter battery. There's a little interface board here with some dip switches and just miscellaneous circuitry, and here a little processor in there. So this doesn't actually do a lot. The key parts are the transceiver chip, the power amplifier, and the antenna switch, or the switch that bypasses the power amplifier for when we're receiving. Really simple stuff. And it's amazing. This is probably why this system is so cheap. There's not a lot of silicon involved in these modules. As you can see, there's we've got a microcontroller on the back. It's probably an STM32. I can't actually see, but I'll put a note on the bottom here, let you know what that is. And some crystals. I think, what are we looking at here? Oh no, I can't see. What have I got? The trouble when you do these things is a couple of inductors. Like this is for the power supply. Then we've got power supply. These chips usually only run on about 3 volts, 3 to 5 volts. So you have to drop down the voltage from your transmitter to that much lower voltage. And that's pretty much it. Now, given that this is running all on 3 or 5 volts, I'd probably say, looking at those inductors, I'd say 2S LiPo is all you'd want to use on here. I wouldn't go for 3S on this connector. It's probably going to cause things to overheat a little. I could be wrong, but just looking at the components they've used, I'd say 2S would be a good size for powering this thing through the external power connector. Apart from that, not much. There's the cable up to the SMA connector. It's soldered. It's not. There's no connector on there, which is quite handy. It means you don't have to worry about that connector coming off. And there's the pins that go into. Where are we? What have we got? Where's the back of the module? Here's the back of the module. There's connectors here, and there's another pin set there. So yeah, not much more to say really. What's that big piece of? Oh, this is just a heat. Oops, where are we? I think that's just heat via. We've got a big chip on the other side. Yeah, that's the transmitter. That's the 2-watt amplifier. So what they do to try and, because when you're creating 2 watts of radio frequency power, that's a lot of energy that will also be turned into heat. So, because it's not 100% efficient. So over here, this area here, notice all these little holes, they're called vias. It tries to conduct the heat through the board to this area here where it can radiate it. So it's just a big heat sink, a big radiator to try and keep that chip cool when you're running at higher power levels. In fact, probably could do with a little bit more heat sinking than that, but I guess the component's rated to the necessary power levels and it should work. But on a really stinking hot day with no airflow, that could get real toasty. I'm not going to test it out, but maybe I will in future if there's a problem with those. There you go. That's the transmitter module. Let's take a look at the receiver. And here is the R9 receiver. Now you can see, look, I've unplugged the antennas because I don't want to tape those from the model I already installed, so I can unplug that. That's great, isn't it? So the other end, we've got some fairly standard 3-pin connectors. You can see we've got a range of bits and pieces on there. I can't actually see through my thing. We've got some smart bus and so forth, S bus, and what's that up here? This is S port up here. So yeah, it's littered with connectivity, and it's the same size as the X8 and so forth, and the L9R, those receivers. So it's a pretty standard size for a 8-channel receiver. Looks like it, but that's just with standard servo outputs. Being S bus, it's probably a 16-channel receiver. I don't know. I'll check on that and let you know. Right, let's lift the dress on this little baby and see what's inside. Okay, there we go in all its gloriousness. This is the inside of the R9 receiver. And what have we got to see here? Well, there's a Semtech LoRa chip here, this big fat baby there. That's the thing that does all the hard work, that does the sending, the receiving, and all the digitally stuff to make your commands into radio signals or receive radio signals, turn them back into commands to drive the servos. That does the RF side of things and the packaging and all that sort of stuff. Here are our 2 antenna connectors over here, because this receiver obviously does have antenna diversity. The little receiver doesn't have antenna diversity, but this does. Now, down here we have some little chips. These ones are just switches. They're like little relays. They're solid-state relays, effectively. They enable these antennas here to be switched to the chip over here, because the chip itself doesn't support directly antenna diversity, and FrSky have added antenna diversity by adding these little chips here to switch the antennas. That's kind of cool. That gives you a more reliable, more robust signal link, and then you can have antennas at different angles to cope with the changes of polarization as the model banks and turns. It's kind of neat. So there's really not a lot else, is there, apart from that? There's this basically the chip that does all the hard work, the antenna switches, and all the rest in here is pretty much just support circuitry. That's just stuff designed to make these chips feel happy and at home. So the quality, the build quality is very nice. I'm quite happy with that. The soldering's nice. The layout looks pretty good. That's it. Not really a lot going on that board, is there? And on the other side, we have all the digital stuff. This is the stuff, once we get the signal out of that LoRa chip, it's turned into a whole lot of binary data, which is then fed into this, which is an STM32 32-bit microcontroller chip. That's the computer, that's the brains. It sorts out all the ones and zeros and sends them off to the servo connectors along the side there, and the smart port and the S bus and all that sort of crap. So that's it. It's really, when you look at it, there's not a lot in these receivers. That's why they can be so cheap. The price is remarkably low for the functionality and the performance you get. And so, yeah, we should all be cheering and waving madly at the lovely luxuries we get with this modern technology. So that's really it. There's nothing else to see. Nothing to see here. Move along. And I suspect that when we lift the skirt on the little receiver, we're going to see the same chip here and just one of these switches, because it only has one antenna, so it only needs to switch one antenna. As I said, this chip here only has a radio, sort of an out and an in, so the antennas must be switched between the in and out pins, depending on whether it is listening for the transmitter in your hand or whether it's actually sending back telemetry information. Because it's a telemetry receiver, it transmits as well as receives. There you go. What can I say? I like it. I like it a lot. Okay, we've had a look at the R9 receiver. Let's take a look at the little one here. I mean, what's the difference? Why would you make an R9 when you can fit it all into something this small? And I think the major difference is going to be the receiver antenna diversity. In the R9 we saw we had those two switch chips that were switching the antennas, because the LoRa chip itself does not have built-in receiver and diversity or antenna diversity. So FrSky have added some extra circuitry to give it antenna diversity. Now this just has one antenna, as you can see. If you're going to look for areas where the antennas can be improved, this is it. I mean, we've got a balanced antenna connected to an unbalanced feeder. That's not really a good look, but I'll get onto that in a later video. Here we go now. Let's take the covers off and see what's missing, because obviously something must be missing or it would be the same size as the R9. Okay, we've lifted the skirt on it and let's have a look what we've got inside. Well, it's exactly what I expected. Let me find something to point with. I'll use my little sharp knife because it's got enough of a point. Now, right, down here we've got another one of those little solid state switches. Why do we need a switch? Because we've only got one antenna. Well, these chips, the Semtech chips, don't have just one antenna pin. They have an antenna pin for transmitting and one for receiving. So this little switch here has to switch the antenna between the transmit pin and the receive pin on this chip here. So depending on whether it's transmitting telemetry information out or whether it's listening for the signal from your transmitter, this switch has to flick backwards and forwards to connect either the receive pin or the transmit pin on this big chip here to the antenna. That's what that little chip's for. But there's no antenna diversity. It's only going to use the one antenna. That's why this only has one of these switches and why they're able to make it so much smaller. Also, this has a little micro UFL connector. It doesn't have the rather nice connectors the R9 has, and it doesn't have full-size pins. It's only got this little JST type connection here. So there are compromises involved in making things really small. On the flip side, well, there we go. There's our STM processor, same as in the R9, and here's just some support circuitry, voltage regulators and so forth. So this is it. So will this have the same range? Well, it should have pretty much the same absolute range, but because it doesn't have receiver antenna diversity, you're probably going to find that this will produce more dropouts as you're getting close to the limits of range. It'll be more sensitive to the antenna placement because you only have one of them, so the antenna could be more easily shielded by things like the carbon fiber spars and things like that in your model. So a little bit more care required when installing the antenna on this one. But yeah, it is going to be pretty much, if you don't, also the issue of smart ports and other things that the R9 has, a lot more connectivity on it. This is fairly limited. There's the sticker, so you can see all the pinouts and things if you want to see it. But yeah, so for small models where you just want S-bus out, maybe and I don't know if this does telemetry or not. I have to check. Oh, it must do because it has a switch. Otherwise, the receiver switch would only be connected to the one pin on the thing. So it must do telemetry as well. Although I will check on that. Maybe I'm wrong, maybe I'm not. I will put a little note just here to tell you whether it's telemetry or not. Should have checked that before I started the video, but So there we go. That's the R9 Slim, and it's a pretty schmick looking piece of kit. I'm not going to weigh it because it probably wouldn't even register on my scales. And that is the R9 system on the bench. And I can tell you that I did take the Tomahawk. Let me just pull out a bit here so you can see it in all its glory. I took the Tomahawk for a bit of a burn on the weekend to the limits of visual line of sight on 100 milliwatts and didn't have a problem. So I fully expect that this is a system that will produce many Ks of range. I can't legally test it. If I tested it and showed you the results on this channel, they'd come and lock me up. And it would also set a bad example for others. Having said that, when it comes to the issue of beyond visual line of sight flying, I know that many, many people in the hobby have been doing it for many, many years. And I've not heard of one single instance where this beyond visual line of sight FPV flying has resulted in injury or accident. So I think the risks are greatly overstated, but nevertheless, the rules say in most countries you can't do it. So do it at your own risk, and if you're going to do it, and then be safe about it. Stay below 400 feet, and just fly in areas where you're not likely to encounter other full-size aircraft, and where you're not flying over anything that might get damaged if something goes wrong. My general rule of thumb is never fly further away than you would like to walk to recover the model. But there you go. That is the FrSky R9. Now this is supposed to be very similar to the Crossfire from Trappy from Team Black Sheep. Let me just put that there so you can see the module in all its glory. Supposed to be very similar in terms of function, in terms of the design to the Crossfire system. And I know there has been a little bit of bad blood between Trappy and FrSky because Trappy says, we invented this and you've just come along and copied it, which of course isn't really true. Lot of manufacturers will be using the LoRa chipset in all sorts of devices. And what happens is generally when you get a chipset, you get what's called a reference design, which is just basically how to connect all the components to it to make it work. And I would not be too surprised if, looking at the circuitry, the FrSky system and the Crossfire system are pretty similar in terms of the components they're using and even the layout, because it's quite common to just copy the reference design, make a few tweaks and integrate that into your own product. It saves a lot of time and effort, and it's going to work. So it could be that the hardware designs are not too dissimilar between Crossfire and the FrSky system. That doesn't mean either of them have copied the other. And really, the secret sauce, the thing that's going to make one better or worse than the other, is the software. All this stuff, all these chips are driven now by software. There's an onboard 32-bit processor telling that LoRa chip what to do and how to do it. And if they get that wrong, then it doesn't matter how good the chips are, it'll be crap. Okay, so the difference between the Crossfire and the FrSky is going to be down to the quality of the programming and the feature sets that are built into that programming. And I'll be looking at that in a later video, as I'll be looking at the Crossfire system, and then we'll do a side-by-side comparison. Just from the top of my head, my experience to date, I would say that both systems are pretty damn good. Just as, you can buy a Toyota Corolla or a Lexus, and they're both pretty damn good cars. They both get you from A to B. This is the Toyota Corolla of 900 megahertz long-range systems. The Crossfire would be the Lexus of 900 megahertz long-range systems. Both will do the job, but if you like a bit of luxury, if you like a few extra features, if you like a really flash cup holder instead of the cheap plastic one, you'll buy a Lexus. You'll buy Crossfire if you want all the extra features that Crossfire offers. If you're just an average guy who wants to get from A to B in the cheapest, most efficient way possible, you'll probably go for the FrSky because it's no frills, low cost, and it seems to just work as advertised. There you go. Two different products for two different parts of the market. And so I don't really see why we have this big sort of war going on between the two companies. They're both addressing different parts of the market with different products, even though they share the same chipsets. Rightio, that's it. That's from me for another video. Now, if you've got questions, comments, anything you want to know, please put it in the area provided by YouTube for the purpose of... It was convoluted, wasn't it? Anyway, just leave your comments below, and I'll do my best to answer them and address them, and basically see what you're saying. I want the feedback. I want to know if I'm doing it right. And I will be doing some more flight testing of this in mini quads as well as on fixed wing and we'll let you know how that goes. But next time, I'll be looking at the Crossfire, doing the same thing with the Crossfire, throw it on the bench, pull it apart, with the caveat that I have a very early Crossfire system. It was one of the prototype systems, so it may not be truly representative of what's on the market today, but it'll give us a pretty good idea as to how it's going. So there you go. For me, the R9 system from FrSky, it's a thumbs up, as most FrSky products are, not unfortunately, but unsurprisingly. And at the giveaway prices, they were flogging them off a little while ago, how could you not buy one? I mean, go out there. Disclaimer, this was provided by FrSky for the purposes of review, and that's what I've done. I've reviewed it. There you go. Thanks for watching. Bye for now.